Looking at differentiation by first principles, it's an algebraic way of sorting out how to get the gradient of a straight line without using the calculus part of it. It's often done before people study calculus, but I'd rather look at it after so we can make more sense of it. So we've got yourself a curve, maybe it's a cubic, I'm not quite sure what it is, but here's your x and y axes, and we've got this point here. This point can be described as being a certain x value, not sure what it is, and across here I'm going to say that's the function when x is a certain value there, i.e. y equals. So that's our point y equals at that value of x. The aim of calculus when you differentiate is to find the gradient of a tangent at that point. So a tangent at that point is a straight line that just touches that point. That's pointing in the same direction as the curve at that point. So it basically, bring the ruler so it just touches there. That's sort of what we're aiming to get. That's the tangent to the point. Now to do that, we're going to choose another point a little bit further away. We'll do this one in green. So here's another point here. It's got a value on the x-axis. I'm going to say it's called x plus a certain amount. I'm not sure how much the amount is. I'm going to call it h. So from there to there is a distance h. Okay, from there to there. Of course, it's on the function, it's on the graph, so I can come across here and call that f of the new value, my new x value, which is just the old x value plus h. Okay, so I've got two things going on here. I've got my x value is increased to get from there to there, and my y value, my function value, is also increased to get from there to there. You might have seen this called rise, how high it goes from this level up to there, and from there to there can be called run, rise over run. And that of course gives you the gradient, or the slope, or the steepness. The gradient is rise over run. But in this case we're going to say the gradient function can be found as taking the rise, which was from this value to this value, i.e. that number minus that number, that value minus that value. So it'll be f of x plus h, that top y value, minus f of x, the bottom value, all divided by the run from there to there, which is that value minus that value. So it's just x plus h minus x, but of course that is just equal to h. So f of x equals f of x plus h minus f of x all over h. Alright, let's do the same thing again, but this time I'm going to go for a smaller value of h. So I'm going to do a comparison. I've still got my same value of x there, therefore the same value of f of x. But I'm going to make my h value a whole lot smaller. Here it is. There we go. So there's my x plus h, and I've increased a small amount there. There's my h value. And as you can see, of course, it brought that point closer in. This point is closer than this point was. It's also affected my f of x plus h. That's a bit closer as well. So now when I join a line for those 2 points, I'm starting to get closer to my original tangent I'm after. Remember, this is what I'm after here. Because if I was going to say this is a tangent, that's not even close. Look, that sort of in the ballpark, but it's nowhere close to my tangent there. So the gradient of my straight line there is not the same as my tangent. I'm not saying this one is either, but it's getting closer. And what we're going to do is, what would happen if we get closer and closer still? What if I chose another value here and chose to join those 2 points together, or these points, or these points? As we join the points closer and closer together, we're going to get closer and closer to the actual tangent we're after. Now when you get closer and closer to something, we say it's the limit. So the gradient function will equal the limit as h gets smaller and smaller and smaller. As h, the value we added, gets closer and closer to 0, we still have our function f of x plus h minus f of x all over h. And this is a algebra rule to find the gradient of a tangent to a point based on no calculus yet. Let's try an example. Let's try a trivial example. If we got a function f of x equals 3x, or y equals 3x if you like. You know it's a straight line, so it's a constant slope the whole way through. I'm going to use my derived function is equal to the limit as h approaches 0 and put the values in. Now, first of all, I'm going to take my f of x plus h. So f of x plus h is just going to be 3 bracket x plus h. So the formula here, or y equals, you just take whatever your x value is and times it by 3. But my x value is actually a bit more than x, is x plus h times it by 3. Minus the function value itself, so it's minus 3x, all divided by h. And we'll keep the notation, the limit at h approaches, or gets close to that. Now I can expand this. 3x plus 3h minus 3x, all divided by h, equals the limit as h approaches to 0. It's all algebra so far. 3x minus 3x gives you 0, so we end up with 3h over h. So what we can do now is say, well, we can cancel those, and we end up with the answer 3. Well, that's pretty obvious. We know that if f of x equals 3x, then f dashed of x equals 3. You multiply the power out the front, reduce the power by 1. We know that, but now we've shown it by what we call first principles. As I said, that's a pretty trivial example. I'd like to show a different example using a parabola. I'm using a set of axes like this. And let's just go with a parabola y equals x squared, a nice simple one. There we go. So y equals x squared is the shape of the parabola. So our function, if you like, our function is you take whatever x is and square it. I'll just choose a point, I don't know, 2, 4, because I'm interested in knowing what the tangent is at that point. But I'm going to find the derived function by first principles. What do I have to do? We have to find out the limit as h goes towards 0 of my function with h added to it minus the function of x divided by h. Limit as h goes to 0 of the function is you add h to the x, and that's going to be squared, minus, well, it's just x squared, all divided by h. So what have I done? I got my x plus h squared minus x squared. Expand the brackets, you got x squared minus 2xh plus h squared. We've done those a lot already, minus x squared all divided by h. Gives me the limit as h goes towards 0. Well, they cancel. Yep, you saw my mistake. So we end up with x squared plus 2xh plus h squared. So we end up with 2xh plus h squared all divided by h. And we can do some cancellation here. We end up with 2x plus h. Now what happens as h tends towards 0? We're going to get 2x plus 0 equals 2x. Again, it seems a long way round when we could have just done that straight away. But there are some things that we haven't got any rules for that we can use our first principles to do this.